Okay, so we're going to get started with exercise 205 today. And what we're going to be doing over the next couple classes is really building up a set of basic skills in 3D so that you start to be comfortable modeling more advanced objects. I wish this were the kind of thing where I could just give you free rein and say, hey, model some stuff and learn as you go. But you really do need a certain framework to start building from. We will keep kind of going through this. I will slowly introduce some more design freedom for each of you so that you can actually build some stuff that you're more interested in building. But in the meantime, the objects that we're going to build over the next 2 class days are really targeted to build certain skills that I think you're going to need long term. And we're getting outside of it being perfectly rectilinear, but it's still relatively rectilinear. Next class, we'll do some tubes and some sweeps, which is important for you guys to start working toward your first assignment, which you don't have yet. I know. It's okay. It's still a long way off. But we're building skills. So bear with me. We still are not doing comments on these because everybody's making the exact same thing. So the comments are not super exciting because guess what? Everybody's making the same thing. So today we're going to be building a little piece of a concrete bridge or walkway or something like that. And I'm going to go through the process by which I would build it, or I think you should build it. It's also important to note in Rhino that you can very easily build something in a different way. And that's okay. But I'm just trying to show you the strategies that I would employ toward building it. Question? The zoo is not found. That's troubling. So Rhino believes in everything being zoo related. So Rhino Zoo is the server that runs the zoo, and the render engine that McNeil makes is called Flamingo. And anyway, you get the idea. Grasshopper, we're in animals. Try restarting it and see if that'll work. Try restarting the computer. You should have access to it. If their server went down, I'll send an email saying your server went down. Okay, so I'm going to go ahead and start. And what I'll start with is I want to draw the object that's on your handout below. And I'm going to put 0.00 where that arrow is pointing. And in the online version, the arrow's red, so it's a little easier to see. On the copy version, it isn't. So I'm going to start over here using my standard tools. I'm going to go to my polyline tool, which is right here. And I'm going to start at 0.00. And it doesn't matter whether I draw this in the top view or I draw it in the perspective view. I'm going to go ahead and just draw it in the perspective view like that. And I'm going to start at 0.00. So when it says start of polyline, I'm going to go ahead and type in 0, 0, and I'll press enter. And then I'm going to draw a line straight up along this y-axis. So if I turned on ortho, I could just type in the distance, which would be 36 inches, like that. Now, if this was actually meeting code, it probably should be 42 inches. Just saying. Anyway, it doesn't matter because we're not meeting any kind of code. So I'm going to go up there 36 inches. Next thing I need to do is I need to go over by 4 inches. So I'll go ahead and type in 4. I tend to put the quotation mark afterward because it's habit, but I don't really need to because my default units are in inches. So I've gone ahead and I pushed 4, and I'll say enter. And it's in that direction. Now the next piece is 36 inches down and 2 inches over. And so this is one of those challenging moments where if you really understand relative and absolute coordinates, you can come in and use that to your advantage without having to move on. If I didn't understand the difference, I'd have to finish my line. I'd have to draw a little guide that was maybe, let me turn on object snap here, with end, mid, and perpendicular. I'd have to draw maybe a guide that says this is 2 inches over, and then this is 36 inches down. OK, that's good. And then I'll come back in, and I'll go from here to there. And then I'll take this piece and delete it. And then I'll take these, and I'll join them. OK, that was a lot of extra steps. So instead of doing that, if I'm continuing on with my piece, let me start at 0, 0. We'll go 36, 4. Right here, instead of doing that, if I remember that whole thing about relative coordinates, I can type at. In the x first, we're going -2. In the y, we're going -36. So I can flip into saying at -2, -36. And as soon as I do that, it will go ahead and draw that diagonal line for me. That's a much better strategy, and that's part of why I spent time in the first class introducing you to the concept of the coordinate system and relative and absolute coordinates, was because when you start drawing an object like this, knowing the difference makes it a whole lot easier, and you save a lot of steps in doing it. So I'll continue on. It's going to go straight down the side here by another 6 inches. So I'll say 6 inches. Now here's another opportunity for us to use that coordinate system. So once again, I'll say at, and this time I'm going in the positive x direction by 30 inches. So it would be at 30, comma. We're going down 6 inches, so it would be comma -6 in the y. And I'll go ahead and press enter, and that gives me that slope on the bottom. I'll continue on. Same thing with the relative coordinate. This would be at, again, 30 inches, but this time it would be positive 6 inches because I'm going back up. There it is. Now I can start typing my distance. It would just be 6 inches to there. Again, back to my relative coordinates at -2 inches, comma 36 inches. And there it is. And then we'll go over by 4. Down by 36, and then I can snap to this point, or I can type C followed by enter for close, and that then closes this shape off. So the difference between the absolute and relative coordinates and just drawing by distance can really save you a lot of time if you understand that. So I think this is the first place where I've been able to illustrate the value of knowing that and having that in your back pocket. So once I've drawn this shape, it's time to go ahead and rotate it so it's standing up in the third dimension. So I'm going to use my rotate 3D command, which is the one that we've already gone over before. I'm going to go up to my transform, followed by rotate 3D. Alternatively, I could type in rotate 3D into the command line, and I'd get to the same place. Select my object to rotate. It would be this object. I drew it as a closed polyline, so I only have one object. Could I have done it with segments? Sure, I can still rotate the segments, but in my case it's closed. I'll press enter when I'm done. My rotation axis would be right here along the x-axis, so I'm going to start there and end here. My first reference point would be right up there on the side. I'll snap to that point, and because I have ortho turned on, it's going to snap 90 degrees for me. Remember, if I didn't have ortho turned on, I could also hold down shift to have it snap to the 90 degrees. So let me do it again. Here we go, rotate 3D. First rotation axis, second rotation axis. Angle or first reference point would be right there, and that's it. I'll come back and double check you. Yeah. Yeah, it's on the little handout right there. Yeah, so we're going up 36, over 4, and then keep going from there. So this is snapping straight up. I'm going to hold down shift so that it is snapping straight up, and there is my object, the one that I just drew. So at this point, we're going to go through a couple options. I'm going to show you one way, and then I'll show you another way. There's always multiple ways of making a particular shape. It's just the nature of it. I'm going to go ahead and copy this so that I have a couple versions of it so that you guys can see me do it a couple different times. And I'll show you some of the different strategies. The first strategy would be to take this, and I'm going to go ahead and explode it to simplify it. And then I will take this whole shape, and I'm going to copy it. So I've typed copy again. And I'm going to go back by 4 feet. So I'll turn on ortho and type in 4 feet, and that gives me the second copy. Now, what I want to do is I want to make a solid surface that goes around this object. So I could take this line here, I could take that line there. With them selected, I could go ahead and type loft or go up to surface and then loft, and it's going to build a surface. Let me switch over into my shaded mode so that you can see it a little bit better. There's my surface. And now I'll proceed with all the rest of the lines. So those two, and then I would say loft. I'll take the two at the top here, and say loft, and you get the idea. While these are still joined together here, I could copy them and move that back by 4 feet. And I could take these two shapes as a whole, and I could loft them together. I could go to Surface and then Loft. The default options here are fine, and I'd end up with an object. So that's obviously a lot faster. Where you can get messed up, however, is when you do the loft, you have to pay attention to where what is called the seam occurs. So my seam is occurring right there, and my two directions are in this, that my arrows are pointing in the same direction. If I moved, for example, this point to there, they're still in the same direction, but the points don't match. When I go ahead and create the loft, it's going to give me some funky geometry. So it's something to be aware of that you have to pay attention to. Furthermore, if I went back to loft and I switched the, come on, let me switch the arrow here. There we go. If I flip the arrow, they're in the same points, but they're going the opposite directions. I'm going to end up with a nasty little self-intersecting surface there. So if you're going to loft closed poly surfaces, you want to pay attention to that seam and the direction of the arrows. It's very important. So I'll go back to loft. There they are in the same direction. Rhino's pretty good at figuring out what you want. And there's a way of building these shapes. I could ultimately explode these as well. Another option. If I took this and I extruded this, that would work. So I could go up to Curve, Extrude Curve. Excuse me, where is it? It's under Surface, sorry. Extrude Curve Straight. There we go. And it's defaulting into the direction that I wanted, and all I would have to do is press 4 feet, and it would build that for me. Remember also that when you do the extrusion, you can choose to make the object solid, and say 4 feet, and that's going to make the object solid like that. So there's multiple ways of doing this. The one other way of creating a second copy of this line would be to use the offset tool. So I could go in and do an offset. I want that offset set to 4 feet. Now there's a problem here in that when I do this offset, it's going to make that shape. I want the offset to go back in space. So in that case, when I do the offset, it's a matter of switching your views into one of the side views. Oh, look, I have to go back into in C-plane. There we go. In which case, I can switch it to have it offset the curve in that direction. I just copied it. It's just another way of doing it. So I'm showing you these as a variety of strategies so you can see there's always multiple ways of building this particular shape. Truth be told, if I were building the shape, I would probably build it this way. Make one more copy here. Instead of drawing these symmetrically, where I have one half, where I have this all the way around, I would draw just one half of it. So I would start in the middle here, and I would draw over. I'm just tracing over for simplicity's sake here. I'd end up with this, and I'd make a quarter of this shape, and then mirror and mirror. So I'd take this and offset by 2 feet. There. I'd take these two and loft. And then I need to fill in this surface. We'll get to that in just a second. But I would essentially take this and then mirror. There. Take both of them and mirror right there to build it out. So I'm saving myself the trouble. I'll come back to this idea and show you why it's even more valuable a little bit later on. So we'll keep it there as my option. So let me come back down here to the first option. Actually, I'm going to skip over the first option and work on this second one for just a second. And in this version, it's see-through. So I need to fill in these surfaces on either end. And so I'm going to do that using the surface from 3 or 4 corner points. Makes my life easy to do it that way. So I'll click on that, and I'll start here in this upper corner and go 1, 2, 3, and 4. That builds that surface. Same thing as I go down, I'll do this side, 1, 2, 3, and 4. Now when I get down here at the bottom, I know what we're ultimately going to be doing with this. And yes, technically, I could go 1, 2, 3, and 4. But that's going to cause some problems a little bit later on. So trust me for a second. And sorry, I didn't quite snap all the way on that one. Let me try that one more time. There we go. And do a small triangle in the corner. So 1, 2, and 3, enter. And then do 1, 2, 3, and 4, like that. This is going to help out our geometry a little bit later on. I'll take these two pieces, I'll mirror them so that they end up there. Then I'll take all of the pieces that I just created. I'm holding down Shift to select all of them. And then I will mirror them across the middle of my object. Whoops, helps if I snap to the middle. There it is, right there. And that gives me the back side. So the alternative is this one, in which we did the extrusion, and we chose to make it solid. This makes everything, this is all one surface. It's not split up yet. And so this is fine until we get to the next step. And I'll show you how we need to fix it as we go forward. Obviously, my little quarter of this, I would just fill in 1, 2, 3. Come on. 4. 1, 2, 3. 1, 2, 3, 4. There we go. So I'm filling in that piece. Obviously, you're not going to be making all of the options. I'm just showing you the options as we go. OK, so now in a typical, I'm envisioning this as a little piece of concrete. And typically on the edges of concrete, when you're building a section like this, having a sharp edge is dangerous from formwork standpoint because it has a tendency to break. And so if you look around at concrete, the benches out here are a perfect example. The edge isn't sharp. It has a chamfer on it. So we're going to create that same kind of a chamfer on this shape as well. And I'm going to do that using the Chamfer Surface tool. It's available under Surface and then Chamfer Surfaces. Or you can type in Chamfer SRF for Surface. Be careful because plain chamfer is for curves and it won't let you do it. So it has to have the SRF. And so I'll go ahead and press Enter. As I look at my Chamfer Surface command here, I have the ability to change the distances, which I do want to do. So I'm going to click on Distances, or type D for distance, and I'm going to choose the first chamfer distance of a 1/2 inch, so 0.5. And I'll go ahead and press Enter. My second chamfer distance by default would be 0.5. That's what I want. I can just press Enter, or I could type in 0.5 again and press Enter. And you'll see that my distances are now reflecting that change, 0.5 and 0.5. This, by the way, will be obvious if you don't change the distance. If you do it at 1, it will feel too big. So I have that set, and it's going to ask me to select the first surface to chamfer. So I can go ahead and select this surface here, and then that surface as my second surface. And you can see that it's come up, it's beveled the edge, and it's gone across the top. I'm going to repeat that command. I can do that by going up to the Surface menu and choosing Chamfer Surfaces again. I could also just simply right-click the mouse, and it will repeat the most recent command. So I have Chamfer Surface set up again. I'm going to select this surface and that surface to create that chamfer. I will repeat the command again, Surface, Chamfer Surfaces, and I'm going to do this surface and this surface. So I have that. There's some errors in here. That's OK. I'm going to repeat this one more time. I'll go to Surface and then Chamfer Surfaces. And I'm going to pick this piece and that piece. OK, well, now it's really starting to look a little funky there in the corner. Let me do it right here for these two surfaces. I'll right-click to repeat this surface to that surface. So now I have the chamfers, which look pretty good, but the corners look kind of messy. So I'm going to zoom in on this first corner, and I need to fix the geometry of the corner. It didn't work quite right. And this is one of the things that you're going to have to learn in Rhino, is sometimes you do a command and you need to do a little cleanup work to make the surfaces match up and look good long term. So this cleanup ends up being fairly easy to do, and I'm going to show you how to do it. First thing that I'll do is I'll use my polyline tool right here to draw a triangle. And I'm going to draw that triangle from this corner to that top corner and back down to this corner. And then I'll go ahead and come back to where I started or press C to close, either way. And now I have that triangle right there in the corner. Now, many of you will notice when you start working on this, and this is part of my strategy for today as well, when you go to orbit, I've just drawn this and I want to kind of look at what's sticking out, and I want a little bit more detail. When I go to orbit, my model moves out of the screen. I can't really see it very well. I'm going to show you guys a trick right now that will help change that. We're going to use the zoom command, so I'll type Z for zoom. And with the zoom command active, the standard option is to drag a window to zoom, but there are a few other options. There's an all if we wanted to see everything. There's an extents if we wanted to see everything that I've drawn. The other option is right here for selected. So I have this triangle selected. I want to zoom selected. When that happens, it will recenter the whole view around the object that's currently selected, which means that if I orbit, it's going to orbit keeping that triangle right in the center of my view, which is very, very convenient. When I'm done, I can go back to zoom all, or I can move on to just another object. So I have that selected, and I can see here what's going on. I have my chamfers, that's good, and it's hollow, but I've got these two pieces of surfaces that are just kind of hanging out there. I need to get rid of those. So I'm going to go in and use my trim command. I have that triangle still selected. I will choose the trim tool, or I'll type trim, or navigate to edit and then trim. And I'm going to get rid of these pieces that are sticking out past my triangle. And there they are. When that's done, I'll go ahead and press enter to finish. And then I need to fill that little piece in. I can do a surface from 3 or 4 corner points and pick 1, 2, 3 and press enter. And that then fills that little corner in. Let's do it again over on this corner. I'll start with my polyline. I will draw from this corner to the top, back down and across. Remember, I can type C for close, or I can go ahead and just click on the place that I started. I'll select that curve. I want to orbit around that curve now, so I'll type Z for zoom and then S for selected, or I could choose selected from the list up above. That lets me orbit around and see what's happening. Perfect. Time to go ahead and trim. I'll go up to use my trim tool, or I'll go to edit and then trim. Or of course I could type trim. And I'll get rid of these pieces that are extra. And there's that. When I'm done, I'll press enter, and then it's time to fill this piece in. So I'll go back up to my surface from 3 or 4 corner points, and I'll do it 1, 2, 3, and press enter. We do have the option of keeping this selected and using the patch tool. This would be under surface and then patch. I would change my U and V spans to 2 and 2 and say OK, and this should fill it in. Sometimes the patch tool is a little risky because if there's a slight kink to your lines, it'll make a bowl-shaped piece that's bigger than what you want. So just be aware. But in this case, I know that triangle was coplanar, so it's not that big of a risk. So I'll continue on, and I would work on this back corner, and I would work on these 2 corners. Do you now see part of the reason why doing just a quarter of it has its advantages? I do it once. Now for you guys, I want you to actually do all the corners because you need the practice. So it's not a bad thing at this stage of the game to just go ahead and do it all. But be aware that that is something that can save time long term. So these 2 upper corners turned out real nice. As we come down here, you can start to see why I separated out these triangular surfaces a little bit differently. We're not going to worry about this edge at all, but we are going to work on this edge right here. So I'll go ahead and come back to Chamfer Surface, and I'm going to chamfer this surface to that surface. Well, the good news is that made a nice seam anyway, so we don't have to worry too much. Now as I come down here to the bottom, and I repeat that chamfer surface, and I do this and this, we've got a little bit of a problem. See how those don't quite meet up? That's because this obviously is on an angle. So that becomes a little bit problematic. If I were rendering this as an output, and I were rendering it from right here, could you tell? Nope, can't tell at all. Wouldn't make a difference. So why do I care about that? It could mess me up in the long run. Any idea why it would mess me up in the long run? It's okay, it's not aligned. The big thing that causes this to be a problem is if I wanted to 3D print this object, and that's open, it won't 3D print. So it's good to get in the habit of being clean when you're modeling. Does it really matter if I had no intent of 3D printing this? I mean, obviously, we're not going to go 3D print this today. So does it really matter? No, because I'm not going to 3D print it. But if there's a chance that you'd end up 3D printing, this is something that you would want to correct ahead of time. So I want to walk you through how to correct it, because there's a variety of ways, no surprise, for that correction. So let me come in here and let's take a better look at it. So the problem is that this point is higher up than where this point is. I have a couple different options for, quote, fixing it. First option is I could do a surface from 3 or 4 corner points and just make a little surface right there. It's not clean. It's got a little kink to it. Again, would you see it? Probably not. That's option 1. Second option here would be to draw a line that goes from this point down to that point. Use this line here as a trim. So I'll go in and trim, and I'll trim off that extra surface. I can then go in and take this surface that didn't work right, delete it, and do a surface from 3 corner points. 1, 2, 3, 1, 4. Now this surface that I just created actually has a slight bend to it. It changes. It's a lofted surface. It will 3D print fine. It will unroll fine. But it has just a little bit of a bend to it. Definitely something you would never notice in the model. So that's certainly an option. Let me move on over to this side, and I'll show you how to do it slightly differently, just so that I don't have to repeat myself. So here we go. I'm going to do a chamfer surface, this to this, repeat the command there and there. Same issue applies here. So in this case, I'm going to actually modify the surfaces a little bit to make them fit. So in this example, I'm going to go ahead and turn my edit points on. So if I come over here, there's 2 options. There's a points on, and there's an edit points on. In our scenario, because it's a surface, I think we have to use the regular points on command like that. This points on works only on the curves. Now when I turn those points on for my surface, see how I get that dotted line coming down here? The original surface went to there. That's the original corner, not the modified corner. So I want my surface to go back to where the original corner was. And I can do that by using a command called untrim. Untrim is the opposite of trim. It gives me back, there's my surface edge, the full surface that I had before. So trim isn't permanent in Rhino. Once I have that full surface, I can come back to where this edit point is. Sorry, I have to get out of untrim. There we go. I can select that point right there. I can then move that point. So I type move, and I'll snap it up to be right in line with that. I can come down to this point here. I can move this from that point up to the end there. Same thing with this surface. I can go back in and turn the points on. There they are. I've got a little bit hanging out here that was trimmed. I'll use untrim. And when it says select edge to untrim, you just want to make sure you're actually selecting the edge. When I'm done, I'll press enter. I'll take this edit point right here, and I will move that edit point right up to that point there. So I've done that, and I've corrected it. It has a little bit of a problem because it didn't snap along the way here. See how I have 2 more points and there's a tiny little gap? I would need to take each of these points and move them. Sorry, let me turn on my point snap there and just move it till it's perpendicular Same thing from this point, move to where it's perpendicular. Now it's in line and in plane. So that was a lot of extra steps. Is that the way that I would really choose to do it? Probably not. I think it's faster to draw the line, trim it, and then do a new surface. That's probably how I would go about doing it. But I like to show you that there's these options. There's different ways of doing it. The idea that you can actually manipulate a surface by its control points is a good thing for you to be aware of. Okay, so same thing. I'd work my way up this side here, do the top, and come back down that side. Okay, once we've gotten that gets us through step 9, assuming, of course, that I finished all the way through and what have you. For our purposes, so that you can see the rest of it, I'm going to move to my quarter over here. I'll select it, zoom selected. Let me do my chamfers real quick. There and there, there and there, there and there. I'm just right-clicking in between the last commands to make it fast. There, there. Perfect. I'll come up to the top. I need to clean these up. Oops. Forgot a couple surfaces. There and there and there. So you're watching me do the same thing that I just did, just a little bit faster. I will select this curve, zoom, selected, S for selected. We'll go ahead and trim. And I'll get rid of these pieces that are extra. There we go. I'll fill that in with a patch, or I could do a surface from 3 or 4 corner points. I'll move over to this side and correct it. C for close. Trim. Patch. And there, that's filled in. Last piece is down here. I'll draw a line from there to there. I'll use that line as a trim of that piece. I'll delete this one and do a new surface from 3 or 4 corner points. 1, 2, 3, and 4. So I have that established. I can then take my shape. I can mirror it once. And then twice to get me the whole shape. Again, I want you guys to go through and work and practice and do it multiple times, so don't do it this way, but I wanted to have the full complete object to move on to step 10. So remember last class we worked on assigning a material to your object? We're going to go ahead and go through and do that. I told you every class builds on itself, or builds on the last class. So we assigned a material. I expect you to be able to assign a material, put an infinite plane underneath, and put a directional light in. So we're going to do those 3 things, and I'm going to do it with you so that it's a reminder. As we go forward, I'll start to just assume that you'll be able to do it. So let's continue on and remember that exercise 204 stuff. So first thing I did was I came over here and I created a layer for the environment. I'm going to use layer 5 by renaming it, and we'll say environment. Perfect. I'll create a sublayer on that environment for light. I'll create a sublayer on the environment for infinite plane. Like I said, I usually call it just IP, but since you guys are just learning, I'll actually write it all the way out. There we go. So let's make the infinite plane layer active. I'll double click on it to make it active. And then my V-Ray tools aren't here. If you remember from last class, it was Viz infinite plane. There it is, if I wanted to just do it with the command line. Otherwise, I need to load the tools. So loading the tools was to go to Tools menu, go to the Toolbar Layout, go to the File menu here in the Rhino Options, and say Open. And on your flash drive, you should have your V-Ray for Rhino toolbars. So we can load those in. There they are. And now it's as easy as clicking on the infinite plane button, in which case I'll go ahead and click on it. There it is. So the infinite plane turns out to be exactly level with where the surface of my walkway is here. So I either need to move the infinite plane down or move my objects up, either one. If I move my objects up, I can actually just, they were all on the default layer. I can right click on default and say select objects. It will select all the objects on that layer. And then I can type move to move. Now notice in my move options here, it's set by default to vertical as no. So it just moves in the X and the Y. So if I were to click here, it's just going to move in the X and the Y. If, however, I choose vertical yes, then when I click, it's only going to allow me to move them up and down. So I'll move it up so it's above my ground plane, like that. I'll press escape, and now it's up above the ground plane by a little bit. I'm not worried about it in full context yet, just a little bit above. So I have that now up. I have my infinite plane. I like to lock the infinite plane after I have created it, so I'll lock it, which allows me to drag without dragging the infinite plane. So I have infinite plane, it's on, it's locked. Next thing I need is my directional light. I'll create a helper object, this little box. Actually, I should make the light layer active first. There it is. I'll create a little box to help me out. There it is. I'm going to use the directional light, which is the one on the end with no icon. It's the invisible button. And we'll start at the lower corner, and we'll snap up to the upper corner. Some of you guys, when you switched into your rendered preview mode like this, everything on the ground was black. If that happened, chances are your light is perfectly parallel with the ground as opposed to being up on an angle. So make sure you create the box and get it up on an angle as you start to do that. So I have my light up on the angle. It's now time to assign a material, to load and assign a material. So I'll go ahead and go to my V-Ray material editor by clicking on the button with the M on it, or I could go to the V-Ray menu and choosing material editor from that. I could also type in Vismat Ed, and that would get me to the material editor here. I'm going to right click on Scene Materials and say Load Material, and I said this was a concrete bridge, so I'm going to go find some concrete. I'll go into my Resources folder. I'll go into V-Ray. There's my V-Ray materials. I'll go into concrete, and I'm just going to pick the basic concrete. That's fine. And I'll say OK. There's concrete. There it is. We're going to assign this. Now remember, I can assign it by selecting the object and right-clicking on it and saying Apply Material to Selection. Or, this would be good, all of my objects are on the default layer, so we can go ahead and just apply it to the default layer. So I'll right-click on concrete. I'll say Apply Material to Layer, and then I'll pick Default as my layer choice here. And they're all going to have concrete on them. I could switch into rendered mode to see. Yep, it does have concrete applied to it. That's good. The texture might be too large. That's OK. We're not going to worry about that. That will come in a week from today. We'll deal with the textures. So I have that ready. Now it's time to do a little rendering and see what it looks like. And so I'll go ahead and click on the Render button. All right, and there it is with the material applied. So that's what I'm asking you to do in part 10. You'll do the rendering in part 11, and then in part 12, you're going to post this to the course website by the end of class today. A couple other things to note. I didn't worry about the fact that there were still lines. See how I have these lines there? I didn't worry about those lines because when you perform a rendering, all the lines go away. It's part of when you switch into your rendered view like this, things like the sun and the lights, they disappear. So be aware that when you're in the temporary render preview, that can change things a bit. So once you have your object set up, you're going to go ahead and render it, and then you'll post that by the end of class today. This is very much about the skills and the practice of doing the chamfers, learning how to zoom in and zoom out, recentering your objects, doing the trims, all of that sort of thing. So I expect you to actually go through and do all the corners rather than do the shortcut method that I did with one set of corners. But I also want to show you the strategy of if you look at an object and it's symmetrical, do part of it and then mirror it later on, because that will definitely help you to model faster. faster. Okay, so I'll turn you guys loose to work. You have the rest of the class to work on this. You do not need to comment on this because everybody's making the exact same thing. Okay? I'll come around unless it's a question for everybody. No, okay. Everybody or, okay.